Alright, if you followed the previous 5 videos, you've arrived at the big one. This is where we actually do some trig. Everything so far has been about angle measure. It's been about redefining angles as rotations and redefining angle measure using these new things called radians. And now we're set up to redefine sine and cosine. I say redefine because almost everybody watching these videos will have learned about sine and cosine using the silly acronym SOHCAHTOA. And good news and bad news. If you know SOHCAHTOA and you use it, that's great. That's good news. You know some stuff about trig. Here's the bad news. SOHCAHTOA is not the most important and best thing to think of first when you think about sine and cosine ever again. It's not. From now on, there's a new definition of sine and cosine that does end up being equivalent to the SOHCAHTOA stuff. But you need to file SOHCAHTOA under secondary important things. That's a weird thing to file in a filing system like that. That would be under S, under secondary important things. I don't file things that way. But anyway, that's all I can think of. All right, so here's how the definition is going to work. We have to think about this question. How should we define, say, the sine of theta? I'm just going to pick sine right now. We'll do cosine in a minute. If theta is in standard position. This is the big question. So I want you to think about on the unit circle, because every time we talk about standard position angles, we're going to be thinking about the coordinate plane, and we're going to be thinking about the unit circle on that coordinate plane. And we're going to have the initial ray here, and we're going to have a terminal ray. Now I'm going to place the terminal ray somewhere in the first quadrant, but it doesn't matter. But just so that we have some familiarity, this looks like a normal little angle, but eventually we want it to be in any quadrant. But right now, let's just think about it being drawn right there, and let's say that the angle, it doesn't really matter, let's say the angle has rotated to that spot in this way. So there's the angle theta. And I want to think about what the value of the sine of theta should be. Now I said that we're going to redefine it, and I said that from now on we're going to have SOHCAHTOA be of secondary importance. But we do need to think about our old definition came from this acronym. So that meant that the sine of theta was equal to the opposite over the hypotenuse in a right triangle. If we had in that right triangle, the angle theta was there, let's say, then the actual sine of theta would be the opposite leg divided by the hypotenuse right here. So this is the opposite, and this is the hypotenuse. Now we have to keep that in mind. That's what the sine of theta is supposed to be, in some right triangle. Now over here, I'm trying to get the sine of this angle theta, and I see no right triangles, I see no opposites, I see no hypotenuses, and I'm thinking, all right, so what do I do? Well, we have to find somewhere in this diagram a place to impose this picture. We need to make or see a right triangle that's already here that we just haven't illuminated. We haven't outlined it. It's here somewhere. And there is a relatively natural place to put that diagram here that seems to honor the unit circle as being of some importance. What if we go up to this point where the unit circle hits the terminal ray? And what if we drop a perpendicular? The word drop is actually, I don't know if you know this, but it was coined because of the idea of gravity. It really looks like something's being literally dropped down if gravity's going this way. Fun fact. So we drop a perpendicular straight down there, and I want you to notice that picture is that picture. And now we actually have an opposite, and we have a hypotenuse. The hypotenuse, there's a right triangle here, and we end up having that this hypotenuse right here, write it in as hypotenuse, it exists, and here's the opposite side. So I guess that the sine of this angle theta is equal to this. It's equal to this length divided by this length. Okay. Here's the thing. I want us to talk about what those two lengths really are in this diagram. Remember, this is the unit circle. The unit circle has a radius of 1. There's one unit out here. This point right here is at 1, 0. This point right here is at 0, negative 1. This one is at negative 1, 0. This one is at 0, 1. And all the points on here, we don't know their ordered pairs, but they're 1 unit away from that point. In fact, in particular, so is that point. Do you see it? That's 1 long. This is 1 long. So it actually turns out that the sine of this angle theta is equal to that opposite side divided by the hypotenuse, but that hypotenuse is 1 in this special picture. Which means opposite over 1, anytime you divide something by 1, that's just the opposite. The actual value of the sine of that theta, the sine of that angle theta, is this length. It's just that length. Now here's even something else that's special. That length is a special thing in this diagram. This is the coordinate plane. That length is a straight up and down length. That's a y value of that point. That point has an ordered pair. It's x comma y. And I want you to think about physically what that means. That x means how far it is across here. That's what it means. And that y is how tall that perpendicular segment is. That's the opposite side. And we realize, oh my gosh, in this diagram, the sine of theta is actually that y value. It's that y value. And that's the new definition of the sine of an angle theta. It's not going to be, I'm not going to draw this right triangle every time. Instead, the new definition of the sine of theta is actually going to be just whatever the y value is on the unit circle of where the terminal ray hits. We're always going to do that because it does match up with opposite over hypotenuse. The new definition of the sine of theta is the sine of theta is equal to y, where y is the y value on the unit circle, or of the point of intersection between the unit circle and the terminal ray of theta. I hope you can get all of that in there. Probably not, but I'll just lower it down a little bit. The new definition of the sine of theta is sine of theta is just equal to y. Like, that's it. But then I have to explain what I mean by y. Where y is the y value of the point of intersection between the unit circle and the terminal ray of theta. All you got to do to find the sine of theta is draw the thing in standard position, figure out by some method, I mean, this could be hard, but pretend it isn't. You just figure out where the ordered pair is. What's the ordered pair? Where the unit circle hits that circle, and the sine of theta is the y value. What about the cosine of theta? Well, the cosine of theta, the old definition was that the cosine of theta was equal to the adjacent over the hypotenuse. Ca, C-A-H. Well, if you look at this diagram, we should make the cosine of theta the adjacent over the hypotenuse. But look, the adjacent is the x value of that point. And the hypotenuse is 1 long because it's the unit circle. And so we end up with the new definition of cosine is equally nice and neat. The cosine of theta is equal to x, where x is the x value of that point on the unit circle. And now, because of these two definitions, we just apply them to any angle, we can actually find cosines and sines of angles that don't exist in right triangles. Because if we pick an angle like 100 degrees, think about an angle of 100 degrees. Before you learned this, If I had asked you, what's the sine of 100 degrees? Your first step would have been to make this picture and say, oh, that's 100 degrees. Wait, I can't make a 100-degree angle in a right triangle. There is no cosine of 100 degrees. There is no sine of 100 degrees. I can't do it. But now with this new definition, you can. Notice that this means that for any angle theta, any angle of any measure, the cosine of theta is equal to the x value, and the sine of theta is equal to the y value in this diagram. So make a unit circle, you make some angle theta, not in the first quadrant, let's say. Wherever it intersects the unit circle, there's an x comma y, that's the cosine, that's the sine. The cosine is the x value, the sine is the y value. And that's it. That's the new definition of sine and cosine. Digest that, think about that, use that. This is more important than SOHCAHTOA. More important. In fact, it's very important that from now on, when someone asks you about sine and cosine, that your first thought is not SOHCAHTOA. Instead, your first thought should be, oh, it's an x or a y value on the unit circle. All right, talk more about this in the next video.